Hello everyone, today we are going to discuss about asymptotic notation. The definition of asymptotic notation is it is used to calculate the time complexity of an algorithm. By asymptotic notation you can calculate best time and average time and worst time. So the first main type of asymptotic notation is big O notation. Let us consider f of n and g of n be two non-negative functions. Then f of n becomes big O of into g of n if there existed two positive constants c and n naught such that f of n is less than or equal to c into g of n. If the f of n is equal to big O of g of n is to be satisfied, then f of n should be less than or equal to c into g of n for every n greater than n naught. The big O H notation can be used in the following instances. For expressing the worst case scenario of an algorithm. The meaning of worst case scenario is if En is maximum, then it becomes worst case scenario. If let us talk about the equation of big O notation, let f and g be two functions, then the equations become f of n is less than or equal to c into g of n. Here c is an constant and it should be greater than or equal greater than 0. The graph of big O notation is here we can consider at axis it is input n and here t of n. If we consider two lines f of n and c into g of n, they coincide at one point. It is named as n naught. Here we can observe that c into g of n is at upper bound and f of n is lower than c into g of n. So by that we can conclude that growth of f of n is less than growth of g of n.
Today we are discussing about asymptotic notation. This is the second type of asymptotic notation, that is big omega asymptotic notation. If t of n is minimum, then it is best case scenario. The best case scenario is used in big omega notation. The lower bound of an algorithm is given by big omega notation. The big omega notation of f of n is given by g of n less than or greater than or equal to c f of n. Here the c is constant. This is the graph of big omega notation. The y-axis is t of n and x-axis is input n. This is f of n and this is g of n. G of n decreases and f of n increases. The intersection of g of n and f of n is got as n naught. So we can conclude here the growth of f of n is greater than or equal to g of n.
Asymptotic notation means it will modify the running time of the algorithm. In asymptotic notation, we can see three cases: best case, worst case, and average case. Here, the leader notation is the average case. Average case leader notation means it is the time between the best case and worst case. Best case and worst case. It is a graphical representation of the leader notation. Here, it is average case. It shows the exact time of the algorithm. Exact time of the algorithm. Where the mathematical representation is C1 into g of n is less than or equal to f of n is less than or equal to c2 into g of n for all n greater than or equal to n naught for all greater than or equal to n. The average cases are f of n is equal to theta of g of n or f of n is equal to theta of n.